Okay guys, hello. So here I just came up with an advanced question. Okay, because JEE Advance is just nearby. So what I told that question says there's a uniform rod which is released on a smooth horizontal surface from rest as shown in the figure. Okay, the rod makes an angle theta is equals to 60 degree with horizontal initially, and some of the questions they have asked, that is, what's the acceleration of center of mass just after release, or the acceleration of point of contact just after release. But we'll try to figure out all the aspects, basically all the aspects of this particular question. What are those? First of all, we need to analyze the motion first. So I can say that if I have this body, first thing that comes out in any possible question you should do first of all is that you should draw always the FPD. So I say that the FPD will be mg, and that's just normal. Okay, so people have a problem, sir, how to approach a question. So basically first you draw the FPD, you will get it, clarify the main thing. Now could you please try to understand that this mg is little bit separated from this point. Okay, so this will try to rotate this point like this. It's very correct. With this rotation, since there is no friction here, so what is slipping will take place here. Will take place. Slipping will take place here. And basically the forces here, slipping will take place. So that means there is no friction, that's why slipping is taking place. That means I could understand first of all that on this block, on this basically the rod one, this, let's say they mark it out point as A. I mark this point as A and mark this point as center of mass as this. This A has a tendency to move in which possible direction? Is it this direction, the rotation? Now, if this is coming to be in this direction, the best part is that where the center of mass having force, the center of mass having only forces in y direction, that's very clear as per the Newton's second law that, sir, the center of mass with respect to ground frame, I am saying with respect to ground frame at that instant, the center of mass will have a force in only one possible direction, that is downward. That means center of mass will have an acceleration just downward straight. There is no confusion here. What I told since the force is in always in vertical direction at that instant from the ground frame, so we can say that center of mass will have acceleration in which direction? It is only in the ground, that is towards bottom direction, that is vertical direction. So it will fall down straight. That will be having ACM. Now ACM and A. Now this is with respect to ground frame, sir. That means if I am standing on the ground and I am seeing, then I'll see like this. Yes. Now I'll say that. That means I'll understand that A and ACM are not same. They're both different. Okay, but I can find a relation between A and ACM. How will I find it out? Let's figure it out. So I'll say that this is the rod. Very good. I'll say that this is 60-degree angle. This is ACUM downward. Okay. This is A. Okay. Can I say this is 60-degree? And this is 30-degree if I'm not wrong. I can resolve this component as ACUM cos 30. Very good. I can resolve this as ACUM sin 30. And this is A cos 6. This is what? This is only A. So I can resolve this as what? Along this direction as A cos 60 and along this direction as A sin 60. Is this all clear? You can understand the acceleration is perpendicular to the rod, that is A sin 60 and A cm sin 30. They are trying to rotate the body. It's very clear. And the acceleration along the rod, that they are trying to move the rod. So I can say we already know, since the rod is what? A rigid body. So in a rigid body, we know a constraint that acceleration along the rod will always be found to be same. That means A cos 60, sir, will be is equals to A cum cos 30. That comes out to be what? A sin 30 will be is equals to what? A cos cum cos 30. Now everyone is good in trigonometry, so I guess A comes out with what? A sin 30 by cos 30 is equals to A cum. So I can write it as A cum is A tan 30. On a smarter move, I can say A cum is A by root 3. Or people, you can even write it as A is equals to root 3 ACUM. That is one of the easiest things. Once you got this, we got a relation. Now we got very happy that, so I know the relation between A and ACM. But the value we need to find, because we don't know ACM also, we don't know even A. So we need to find also. So we need to analyze it out. Now with respect to ground frame, if we are seeing, sir, it is moving towards left also, it is rotating. So it's very typical to understand. So what I'll do, I'll take the help of a concept that is called relative motion. So I say with respect to point A, sir, with respect to point A, if I want to observe, okay, observing with respect to point A. So I'll say, okay, with respect to point A, I'll observe, sir. Then what will happen? Then this point A will behave as red. I just sat at that point. That is, this is behaving to be fixed. As why? Because I have sat on it. And I will apply a pseudo force because I just sat on it. So I have to apply a pseudo force as per the, to make the Newton's law correct. And this is mg. Now with respect to this point is fixed. Now this body, this rod is feeling to be rotating like this. That means it will be having an rotation like this, and it will be having an acceleration called L by 2 alpha, as the radius is L by 2. There is no problem here. It's doing now circular motion. That means with respect to point A, first of all, the trajectory of center of mass is what? Is circle. That you need to understand here. So once you got this point, I think now it's very easy. So I can say that why is rotating? Because of a body rotates only once because it has a torque. So I can say torque net about point A will come out to be what? I about A into alpha of the body. Who is giving torque about A? So there is a normal as well. So I can say just write all the things. So torque of normal plus torque of F pseudo plus torque of what? Mg. That comes out with what? Ia. Ia is what? It's a rod endpoint. So I can say that ml square by 3 times of alpha. And alpha is in which possible direction? That is in minus k cap, because it will rotate like this. Clockwise sense. That's fine. About A normal is passing. So the torque of normal will be equals to what? 0. It can't rotate. Can you rotate a door by applying a force at the hinge only? No, you can't. That means because the torque you are providing is 0. Pseudo force will be what? MA into, when you have to write it out, so I'll just write it here, just check it out here. If I write it out, I'll say pseudo is here, F pseudo, this point is fixed, this is mg. So whenever you have to write torque, how will you write? Check it out. People who have a problem with writing torque, they can extend this force and they can draw a perpendicular distance from here. So this perpendicular distance is L by 2, this is hypotenuse basically, this is theta. Okay, so this I need to get this distance. So basically this is the rectangle part of, or square part. I can say that length will be equals to how much? L by 2, how much? Sine theta. And this length is coming out to be L by 2 cos theta. So it's a rectangle part. So I can say pseudo force, what is the perpendicular distance to pseudo force? That is L by 2 sine theta. So I'll say, right, L by 2 sine theta. And how you tell the direction? Direction you will tell by going from distance to force. So distance is this and force is this. So that you can going in which possible direction? You are going in clockwise direction. So we will say minus k cap. Very good. Plus mg I am writing. So I'll extend the mg. Perpendicular distance on this is what? L by 2 cos theta. So I'll write mg L by 2 cos theta. Very good. And it is coming in which possible direction? So distance is what? Distance is this. This is the distance. So it is again rotating in clockwise sense. That means it is also supporting it out. So this comes out to be like this. Now as I got the equation, I'll write it as, I can cancel them from all the points. I'll say AL by 2 sine 60. Very good. Plus GL by 2 cos 60 is equals to L square by 3 alpha. A I can write in terms of center of mass. So I know that I can write it as root 3 of ACM, which we have found earlier. Just check it out. Here, root 3 ACM into sine 60 is root 3 by 2 into L. I can say that L by 2 here. Okay. And by 2 is already there. So I can write it as plus GL by 2 into 1 by 2. I can say is equals to L square by 3 times alpha. This comes out to be 3 by 4 ACM into L plus GL by 4 is equals to L square by 3 into alpha. Okay, so I got this equation. But the problem with this equation is only one, that I have ACM also, I have alpha also, and I don't know anything. I don't know either of this. So I need to get a relation between ACM and alpha. So how will I find? Now this is one of the most important concept here that we need to understand here. So we'll see that if I see this particularly, let's say with respect to A, I'm observing with respect to A. So I'm observing with respect to A again. So I'll say that with respect to A, this point has an acceleration called A relative, that's going backward with respect to me, and it has an acceleration ACM. And these two vectors are 90 degrees. So with respect to this particle is doing a circular motion, and its net acceleration is L by 2 alpha, because this is a radius of L by 2. Is that clear? So I got this expression. So I can say one thing by using the vector concept. I can say ACM square plus A square plus 2ACOM into A into cos 90 sir will be root under, will be is equals to nothing, it's L alpha by 2. It's very fine. Cos 90, this comes out with 0. I can get this as ACOM square plus this I can edit as root 3 of ACOM whole square will be is equals to L alpha by 2. That comes out to be how much? 4ACOM square root will be is equals to L alpha by 2. That's come out to be what? ACM will be equals to L alpha by 4. Yes, I got a relation between ACM and alpha. Look, this is very easy. So I got equation number 1 and equation number 2. So what I'll do? Putting the value of 2 in 1, what we get? We get it as 3 by 4 L into ACM, I write it as L alpha by 4, very good, plus GL by 4 plus GL by 4 is equals to L square by 3 times. Now I can say that alpha is coming in one side. Yes, I am getting some equation like that. That's right. GL by 4 is equals to what? L square by 3 minus 3 L square by 16. Oh, big calculation. So let's simplify it out. What I'll say? GL by 4 is equals to 16 minus 9 into L square by 48. I can say this is 12 into alpha. L cancel. I got alpha as 12G by 7L. Oh, I got alpha. Very good. As I got alpha, can I say ACM? I already get it. That is L alpha by 4. That comes out to be L by 4 times of 12G by 7L. LL got cancelled. This comes out to be 3. So ACM comes out with what? 3G by 7. Wow, I got ACM as well. Now I need to find A. A was already know root 3 times of ACM. That comes out with what? So that will be 3 root 3 G by 7. Sir, I have found approximately all the answers. Is it okay? That is the main thing. Now let's check it out with this. Let's check it out this concept here. So I can say that checking out this concept here, I can say what is the answers to be marked? First, it would acceleration of center of mass of the rod after release is what? 3G by 7. Yes, we have figured it out. Acceleration of center of mass after release is what? 3G by 7. Yes, so that means the answer comes out to be how much? 3G by 7. Very good. Next, acceleration of point of contact. That means this point of contact was what? I have assumed A. So I got A as what? 3 root 3G by 7. Yes, that answer coming out to be how much? That is 3 root 3G by 7. That is A and C is the most appropriate or correct answer. Now, I need to find extra. I need to ask one more question here. They'll even ask you find the normal reaction or the force given by the ground. Then how will you find? Then let's find it out. Let's find the force given by the ground. That is finding the normal by ground. Here I can't say the normal will be equals to mg. If I saying the normal is equals to mg, that is wrong. Understood? This is not the mg. So what I see that here the body is acting normally above. This particle is acting mg, and this particle is having acceleration ACM, and this is having in this direction. That is A. It's fine. Now I can say that the center of mass, you can understand the center of mass is falling down. So I can say that I can see the normal applying Newton law, that is Newton's second law. F net is equals to mass into ACM. That is translation motion. I can say mg minus n sir will be equals to m into ACUM, which is nothing that mg minus n will be equals to m into 3g by 7. That I have already proved. 3g by 7. That we have already proved it. This comes out to be what? N will be equals to how much? Mg minus 3 mg by 7. I think so. N comes out to be what? 4 mg by 7. Hence we found out approximately each and every aspect. We have seen each and every aspect of this particle. I even get it. Every aspect of this question we can even got what is the value coming in this particular thing, that is tell me what is the acceleration or what is the acceleration of the point of contact, acceleration of the center of mass, or even find the normal reaction acting at the end. If you like it video, please subscribe and please like. Okay, for more update or more questions you want, you just comment in that comment link and give more questions to me just to get solved, and even ask more advanced and mains question as well. Thank you guys.